Welcome to my program. I'm Dinesh Vijayawardena. Today we're going to discuss from continuation of my last topic, which is wave, and today we're going to touch upon electromagnetic waves. So let's get on to the topic. So electromagnetic waves. So when we consider electromagnetic wave, we need to understand what is electromagnetic wave. So if we draw a wave diagram, three-dimensional one, so this is x-axis, this is y-axis, and this is z-axis. So if you draw a wave like this, so this is actually an electromagnetic wave. So if you draw a wave like this, in this particular wave, the direction of the electric field and direction of magnetic wave, the actual position of electric field and the magnetic wave, perpendicular to each other. So if we consider, this is the electric field of the electromagnetic wave, so that's the electric field. And the magnetic field on the other side is perpendicular to the electric field, so that would be like this way, goes this way and come back, it's like that. So that's actually that magnetic field. So this magnetic field is perpendicular to the electric field. That's the magnetic field. Magnetic field. So magnetic field moves in Z direction, and the electric field moves in Y direction. So the actual if your description of the electromagnetic field is the oscillations, the electric field and the magnetic field oscillates perpendicular to each other. And on the other hand, the wave velocity is this direction. The wave's velocity moves this direction, electric field moves in Y direction, and the magnetic field moves in Z direction. So that is the basic term of electric wave. So if we draw these three axes, so this is the direction electric field, and this is the direction of the wave movement, wave direction, and this is the magnetic field direction. Now, so now we need to understand where these electric fields, what are the characteristics. So characteristics of a wave. So for an electric field, so point number one is it does not need a medium, which means no medium required. So either water or air or vacuum, it does not need anything for it can travel on anything. So that's what it means. It's no medium required. So even in space it can travel. So that's why it's electromagnetic field. And the number two is it is a transverse wave. Transverse wave means, as we learned before, there's two types of sound waves. What is two types of waves, which is transverse wave and longitudinal waves. So longitudinal waves is the movement of particle is same as the direction of the wave. Transverse wave is the movement of particle is perpendicular to the direction of the wave. So this electromagnetic field falls into transverse wave category. Now, and as we know, the electromagnetic fields can travel in vacuum. So in physics, we have been given that velocity of electromagnetic wave in a vacuum is 3 times 10 to the 8 meters per second. That's the velocity in a vacuum. In a vacuum. So that's the velocity of the electromagnetic field in a vacuum. So you can see this is a very big number. So if you know the sound wave, normal sound waves that our speaking or music or frequency waves, the radio waves travels in a speed of v equals 743 meters per second. Considering this number and that number, that's a huge difference. But of course, the medium in here is vacuum. Now the last point is that it has an electric field and a magnetic field. So there is got two properties for electromagnetic waves. One is electric, one is magnetic. As you know, electric field and magnetic field. And the last point that we need to put through is that electromagnetic waves is not affected by any other electric or magnetic field. So electromagnetic waves are not affected by any other electric or magnetic fields. So even if there's external field, external electric field, external magnetic field, the particular field, particular electromagnetic field we deal with won't be affected by it. So the properties or nothing will change. Not affected by external fields, which can be electric fields or it can be magnetic fields. So that is what we have to understand, the basic terminology of an electromagnetic field. And next time we will discuss further into what are the further topics associated with these electromagnetic waves. So thank you for listening. Bye for now.